Okay, so in this video here, we're going to be talking about solving quadratics using the square root method. Now, you can use this method if you're missing your bx term. So for example, if you have a quadratic in standard form, we know that's going to be ax squared plus bx plus c. So if you're missing this bx term, you can solve by doing the square root method. And so all of these problems here, we are going to be missing that bx term, meaning I can solve these quadratics by using the square root method. All right, so let's go ahead and try our first example here. Now, your goal is, when you're missing that bx term, you want to isolate x squared, and then from there, you'll go ahead and take the square root on both sides. But again, before you do that, you have to isolate it. So our first step here, we have to take this negative 10 and move it over, meaning I'm going to add 10 on both sides. When I do that, I get 100 x squared equal to 26 plus 10, I get 36 here. So 36. From here, I want to divide by 100 because, again, I'm trying to isolate x squared here, okay? So don't take the square root yet. You have to isolate that variable first. So we're going to divide by 100. We get x squared equal to 36 all over 100, okay? And don't worry about reducing it because these are going to end up being perfect squares, right? 36 is a perfect square. 100 is a perfect square. So I'm going to go ahead and take the square root on both sides, and that will get rid of my exponent of 2 here. Okay, so this will cancel out. Now, remember, when you take the square root, it's going to be plus or minus. So I'm going to write here, x is equal to plus or minus square root of 36 over 100. And that square root is being applied to both your numerator and denominator. So the square root of 36 is going to be 6. The square root of 100 is going to be 10. So you get x is equal to plus or minus 6 over 10. And then if you want to reduce it, you can. We know that 2 will go into 6 3 times and 2 will go into 10 5 times. So x is equal to plus or minus, and then we have 3 all over 5. Okay? And then we can go ahead and box that in. All right? And so again, we know that this quadratic is going to be crossing the x-axis at 3 over 5 and negative 3 over 5. And so just keep in mind you have 2 different answers here, but we can leave it in this form here. Okay, let's go ahead and try another example. So here's our next example. We're going to do the same thing. We're going to add 9, and then we'll go from there. So I'm going to write 36x squared. I'm going to add 9. That will give me positive 1. So I get equal to positive 1. From here, I have to divide by 36. So x squared is equal to 1 over 36. And then again, we're going to take the square root on both sides. That will give me x is equal to plus or minus square root of 1 all over 36. So again, that's being applied to both your numerator and denominator. So when I take the square root of 1, that is just going to be 1. When I take the square root of 36, that will be 6. So your final answer here is going to be x is equal to plus or minus 1 over 6, and then you're done. Okay? All right, let's go ahead and try another example. So here's our next example. This one here, we're going to add 1, and then we're going to end up dividing by 16. So I'm going to get 16x squared. When I add that 1, I get equal to 27. Okay. Then from here, you can go ahead and divide by 16. When I do that, I get x squared is equal to 27 all over 16. And then we're going to take the square root on both sides, like always. So we get x is equal to plus or minus square root of 27 all over 16. Now we have to apply that to both the numerator and denominator, so that's going to give me the following. I'll get the square root of 27, and I'm going to leave it like that because that is not a perfect square, all over, well, the square root of 16 is going to be 4, and again, this will be plus or minus. Now, you could actually go a bit further with a problem because this square root of 27, you can use prime factorization on that, and you can break down that square root. So for example, if I use prime factorization, I know that when I multiply 9 and 3, that will give me 27. 3 is prime, but then I can break down 9. That's going to be 3 and 3. And since I'm dealing with a square root here, if I have a pair, I can take out that number. So I have a pair of 3's here, meaning I can pull out those 2 3's, and it essentially becomes 1 when I pull it out. And this 3 stays behind. So your final answer, you could write this way. You could say x is equal to plus or minus 3 square root of 3, and then all over 4, okay? And that would be done. All right. Okay, let's try 2 more examples here. So here's my next example. This one here, I have to add 7, And you may see something that's going to happen here that wasn't happening in the previous problems, and that is you're going to end up taking the square root of a negative number, but we'll talk about what we need to do there. So if I add 7, I'm going to get 25 x squared equal to, that will give me negative 81 if I add 7. So negative 81. From here, I'm going to divide by 25. So I get negative 81 divided by 25. And then we're going to take the square root on both sides. So I get x is equal to plus or minus square root of negative 81 all over 25. Now, you may or may not have been introduced into imaginary numbers yet, but if you're taking the square root of a negative number, it's really simple. To get around that, you're going to pull out this negative, and when you pull it out, you're going to replace it with I, okay? So in other words, it's going to look the following way. You're going to have x is equal to plus or minus, and then you're going to put I here, and then you're going to say the square root of 81 all over 25. So you can see that the 81 is now positive. We pulled out an I, thus getting rid of the negative, okay? And again, that's going back to imaginary numbers and complex numbers. If you've never seen that before, I'll go ahead and link videos that I've done on both of those topics. That way you have access to that content. So if you're confused about the whole I thing here, go ahead and check out those videos below. I'll go ahead and link them. But from here, I can then take the square root of 81 and the square root of 25. Both of those are perfect squares. And so my final answer is going to be the following. I'm going to say x is equal to plus or minus square root of 81 is 9. Square root of 25 is going to be 5. So I get 9 over 5. And then I'm going to put the I on the end, just like this here. Okay, and then we're done. So I get plus or minus 9 over 5i. All right. Okay, let's try one more example. So here's my next example, and this one's a little bit different because I have like terms here that I can combine, and then I have to take this negative 89 and move it over to the right-hand side, okay? So first, I'm going to combine those like terms. When you do that, you get positive 36x squared. So I'm going to write positive 36x squared. This will be equal to negative 49, because if I do negative 138 plus 89, that will give me negative 49. So I'm going to put here negative 49. Then I'm going to divide by 36. Okay. I'll go ahead and write it out. That way you can see it. Then we get x squared is equal to negative 49 all over 36. From here, we want to take the square root on both sides. And that will get rid of my exponent here. So I get x is equal to plus or minus square root of negative 49 all over 36. And again, to take care of that negative, we're going to pull out an I. And then our numbers will be positive in here. So we're going to do it all in one go. We know that the square root of 49 is going to be 7. The square root of 36 is going to be 6. So putting it all together, we get x is equal to plus or minus. Again, here we get 7. And then on our denominator, we get 6. And remember, we did pull out that negative from underneath the square root. So we have to make sure we put I here so that we indicate that. So I'm going to go ahead and put I here. And there we go. So our final answer here is going to be plus or minus 7 over 6i, right? And there it is. And so that's how you can solve a quadratic using the square root method. It's very straightforward. And remember, you can do this if you're missing your bx term. So if you do not see that bx term in your quadratic, you can go ahead and solve by doing the square root method. And again, I'm referring to a quadratic in standard form when I'm talking about bx, right? ax squared plus bx plus c. So that's going to do it for this video. I hope that you gained something from it. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.